Comment 1628 tells you how to graph an inverse. Now, there's two ways to graph an inverse. This one is telling you just one way. The other way, by the way, is actually to find the algebra for the inverse and graph that. But sometimes, if you already have a graph for the original, or it's easy to graph the original, then graph the original and reflect it in the line y equals x. So, for example, the inverse of y equals root x is y equals x squared. And so what I'm telling you to do is reflect it in that line. So that goes over there, that stays there, and that stays there. I'll give you a more abstract example. To graph the inverse of this, the original of that is this. It's just my general knowledge, by the way, that tells me this. I'm just coming up with an example to show you a more complex reflection. Okay, so what I'm saying is reflect that across the line y equals x. Now, sometimes you can be a bit klutzy in reflecting across that line. So what I recommend is you just isolate key points. So that is 2, 2.5. So you create a new point, which is the other way around. So that's 2, 2.5. So I make one which is 2.5, 2. So 2.5, 2. So there it is. That's 1, 2. So I'm going to make a point that's 2, 1. And that's half, 2. So I'm going to make a point that is 2, that's half, 2.5. So I'm going to make one which is 2.5, half, which is that. And then you connect those, doing your best to mimic the original shape, and just check that it genuinely does look like a mirror situation. So that's what comment 1628 says. It tells you that to graph the inverse, you just take the original and reflect it across the line y equals x. And what you've seen me here is a way of doing that carefully by using the points rather than the graph itself.